4.2, standard form of a quadratic function. So yesterday we did vertex form. Today we're going to deal with standard form. And, we're going to use some of the same resources as Desmos, but there's a little bit of formulas that we need to know here. So the first thing is a quadratic function is always of the form ax squared plus bx plus c, where this a, b, and c are just numbers in front of the variables. They're coefficients. So it's possible that you don't see an x term. That would mean the b value is 0. Okay, so for this, again, the most important point we need to find for the quadratic function is the vertex. So to find the vertex, we need to use the formula negative b over 2 times a, okay? And then you'll see in textbooks, it looks like this, f of negative b over 2a. That just means to plug in x to the original problem, okay, to get y. So again, it's just an ordered pair, and I know this looks like a mess, but as we do an example here in a second, it will make more sense. But again, the most important point for us to find is that vertex. We've got to find the vertex first, okay? And then once we find the vertex, that gives us our axis of symmetry and some other values. So right here, we got a problem. It says, what are the vertex, axis of symmetry, the maximum or minimum value, and the range? Okay, so vertex, I'm going to find by using the formula negative b over 2 times a. Okay, so what am I talking about when I say negative b? B is the number in front of the x value. So it'll be negative 8 over 2 times a. A is the number in front of the x squared. Always, 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 always in front of the x squared. So 2 times 2. So I'd have a negative 8 over 4, which is negative 2. So the value of the vertex is negative 2, comma, I have to find the y value. To find the y value, I'm going to plug it into the original problem. So 2 times parentheses, what am I plugging in for x? A negative 2, plus 8 times negative 2 minus 2. Now we got to do some math here. You can go and plug this into the calculator. I'm just going to go ahead and do the math here. Negative 2 squared is 4. So I've got 2 times 4 minus 16 minus 2. 2 times 4 is 8. 8 minus 16 minus 2. So I've got a negative 8 minus 2. I've got y is equal to negative 10. So that gives me the y value of the vertex. So this is the most important point. I can now answer all of the other questions, right? So this is my vertex. My axis of symmetry is x equals the x value of the vertex, which is negative 2. The maximum or minimum value, because a is positive, right here, this 2 is positive, it's going to open up, which means it has a minimum, and it has a minimum at negative 10, which is the y value. Then again, we talked about the range just slightly yesterday. I do think it's important that we're able to talk about it. The range is the y value, and the y values go up and down. So they're always talking about the y values, and where would the range start here? It would start at negative 10 and go up to positive infinity. If I ask for the domain's always all real numbers. So we're going to have a few questions like this. Again, the key important point is being able to find the vertex using the formula. Now, can we use technology? Of course. You could plug this into Desmos. You could graph it, and it will point to you where the vertex is. I think you should be able to do both. Don't care if you check your answer with Desmos, but you should know the formula. Again, that formula is negative b over 2 times a, and then plug that value into the quadratic. So here's some very important properties of a quadratic. First of all, know that when I'm talking about a, b, and c, a is always the number in front of x squared, b is always the number in front of x, and c is always our constant out here. Okay, you have to have an x squared for it to be a parabola. So this a is the same exact a as vertex form. So again, we're looking at A, whether the parabola opens up. If A is positive, it opens up. If A is negative, it opens down. Things that we've talked about since 2.7, families of functions. The axis of symmetry is x equals negative b over 2a. Well, that's how you find the x value of the vertex. So that's what the axis of symmetry is, okay? And then we define the vertex negative b over 2 times a, and then you plug that value in for y to get the y value. The y-intercept, and this is a new important topic here, is always the order pair 0, comma, c. Okay, whereas c sees that number at the end of the parabola. So there's some important info on this slide that I'm going to ask you in a few problems in Delta Math. Okay, so let's take a look at an example. We're going to go over every single one of those. Okay, I'm going to ask you to find the vertex. I'm going to ask you to find the axis of symmetry. I'm going to ask you to tell me whether this has a min or a max. I'm going to ask if what the domain is. I'm going to ask what the range is. And I'm going to ask what the y-intercept is. So vertex, how do I find it? It's the opposite of b over 2 times a. And if you need to write this out, do that. A equals 1, b equals 2, and c equals 3. So this would be negative 2 over 2, which is a negative 1. So the vertex is the order pair negative 1. Once I find my negative 1, I plug it into the original problem. So y equals negative 1 squared plus 2 times negative 1 plus 3. Sure you do your math right here. So 1 minus 2 is negative 1. Negative 1 plus 3 is a positive 2. So I have the vertex negative 1, 2, which means the axis of symmetry would be x equals negative 1. A is 1, so this goes up, so it has a minimum at 2. The domain is always all real numbers, also written as this, negative infinity to positive infinity. The range starts at the y value, and because it goes up, it would go to positive infinity, so 2 to positive infinity for the range. And then the y-intercept is always the order pair of 0, comma, c, which would be 0, 3. Okay, now if I asked you to go from standard form to vertex form, remember vertex form was y equals a times x minus h squared plus k. Well, this is the x value of the vertex, and this is the y value of the vertex, and this is a. It's the same a as the original, so this would just be y equals a is 1. You can put it, you don't have to. X minus negative 1, which turns into a plus 1, squared plus 2. So to go from standard form to vertex form, it's actually a little bit simpler. I'm going to give you a couple problems, or a problem where we go from vertex form to standard form. That's a little bit more difficult. Okay, so what is the vertex form of y equals 2x squared plus 10x plus 7? Again, I'm trying to put it into this form right here, x minus h squared plus k. I can tell you what a is right now just by looking at it. It's 2. So I can already plug in the 2. Now, how do I find the vertex? Well, I've got to do negative b over 2 times a, which would be negative 10 over 4, which is negative 5 over 2. So I've got x minus a negative turns into a plus 5 over 2. Okay, and then how do I get my k? I'm going to go ahead and plug in negative 5 over 2. So 2 times negative 5 over 2 squared plus 10 over negative 5 over 2 plus 7. So I'm going to square first. 2 times, this would be 25 over 4 plus negative 50 over 2 plus 7. So 2 times 25 is 50 over 4 minus 25 plus 7. Which is 50 over 4 minus 18. And 80, 60, 72. So 50 over 4 minus 72 over 4 is negative 22 over 4, which is negative 11 over 2. So this k would be minus 11 over 2. Again, we're going to go check our math here real quick. Go ahead, use Desmos, okay, and make sure your vertex is right. So this is how you can find the vertex. You don't even need to do negative b over 2 times a if you know how to do this. So it was 2x squared. I believe it was, what, minus 10? Is it minus or plus? This one, it was plus 10x plus 7. So plus 10x plus 7. Here's my vertex. Of course, it gives you in decimals, but the same exact thing that I got right there. Negative 2.5, negative 5.5. I don't care if you use the computer and technology that you have. That's fine with me. But here's what I'm looking for as my final answer. Okay, and don't forget to square it. Okay. Now, you're going to have a problem that asks you to go from vertex form to standard form. Okay, so say I give you a problem that looks like this. You have to remember how to FOIL from Algebra 1. So what does x plus 5 squared mean? We write it down twice. Okay, so now I have to FOIL, which means I need to multiply the first two terms together. Notice I'm not doing anything with this 3 on the outside yet. So that'd be x squared. My outer would be plus 5x. My inner would be plus 5x. So I'd have plus 5x, and then 5 times 5 is 25. Then you got the minus 3 on the outside there. So now inside here we have to combine like terms. X squared plus 10x plus 25 minus 3. Now I distribute. So I'm going to distribute this to all three of these. So it'd be a 3x squared plus 30x plus 75. Don't forget that minus 3 on the end. And y equals 3x squared plus 30x plus 72. So these two equations would give me the same exact parabola, even though they don't look alike. Okay, let's go ahead and do one more of those. I don't think. X minus 1 squared plus 4. Okay, so again, we've got to write it out first. The negative 2, what does x minus 1 squared? It means x minus 1 times x minus 1 plus 4. So y equals negative 2 times FOIL first. X times x is x squared. Outside, x times negative 1 is minus 1x. 1 times x is negative 1x. And then negative 1 times negative 1 gives me a plus 1. Pay attention to your signs. Combine the like terms in the middle. You'll always combine those two. X squared minus 2x plus 1 plus 4. I'm going to distribute now. So y equals negative 2x squared. Pay attention to your signs. Plus 4x minus 2 plus 4. Y equals negative 2x squared plus 4x plus 2. So again, those two should give you the same exact equation if I were to plug those into Desmos. So if I go to Desmos into my calculator and I graph those two functions, okay, which was y equals negative 2 x minus 1. Make sure when you punch this in, you square this. A lot of students forget to square this right here, and it ends up making the problem incorrect. So negative or plus 4. So here's the graph. You can see that it's on the screen right there. It's green. And then when I graph this one, which was in standard form, negative 2x squared plus 4x plus 2. Plus 4x plus 2. You can see that the purple graph lines up right over the green graph. I know I did this right. And again, just some characteristics of this. It goes down. Why does it go down? Because A is negative in both of these graphs. What's the y-intercept? It's always 0, c. Notice vertex form does not have a c, just standard form. So it's 0, 2. There it is. You can find it using Desmos. The range would go from 4 to negative infinity. Domain is always all real numbers. So there's going to be some problems like this on your Delta math assignment. I do have one other type of problem, which instead of it'll be in factored form, and it'll ask you to go from vertex form. So it could look like this, and all you got to do is FOIL. It's just like after you rewrite the vertex form. So this would be 3 times, I'm going to FOIL this kind of quickly, x squared plus 3x minus 2x is a plus x, minus 6 minus 8, you would distribute 3x squared plus 3x minus 18 minus 8, 3x squared plus 3x minus 26. And again, you can always go back and plug those two into Desmos. They should match up and be on top of each other.